Modern agriculture not only creates technological miracles, but also witnesses the magic of nature itself. A single genetic mutation stripped bell peppers of all their heat, turning them into sweet, vibrant gems beloved by billions. But how are millions of tons of bell peppers harvested and processed every year? This journey begins in vast fields and high-tech greenhouses, where countless peppers grow under human care and the rhythm of modern technology before being harvested and brought into processing plants. There, through advanced production lines, each pepper retains its color, flavor, and signature crisp sweetness, before being transformed into sliced peppers in cans, ready to find their way into kitchens around the world. Today, Agriculture Insight will take you inside the most cutting-edge bell pepper factories, revealing the surprising secrets behind this radiant fruit, all of which will be uncovered in this video. If you look at the bell pepper market straightforwardly, the picture is quite clear. China grows the most in the world, Mexico is the major supplier for the United States, and Spain functions as the key distribution hub for all of Europe. These three regions link together to form a massive flow of trade, and it's this connection that underpins a bell pepper market worth nearly $10 billion. In supermarkets, many people assume red peppers are the premium choice because they take longer to ripen and therefore cost more. But from a cooking perspective, each color has its own purpose. Green peppers are crisp with a light sharpness, great for stir-fry and Asian dishes. Red peppers are sweeter and softer, ideal for salads and grilling. And yellow or orange peppers sit somewhere in the middle, easy to use across many types of dishes. So the question isn't which color is superior, it's which one fits the dish you're making. And the idea that light can change a pepper's color? That's completely true. In greenhouses, growers can speed up or slow down the color-changing process simply by adjusting the type or intensity of lighting. It's a very common technique in modern agriculture, but one that most people would never notice just by looking at a multicolored pepper in the supermarket. The most critical factor determining the quality of bell peppers is the timing of harvest. Within just 7 to 14 days, they can shift from green to red or yellow. Pick them too early and they lack flavor and color. Leave them just a few days too long and their crispness and market value drop noticeably. In other words, harvesting bell peppers is genuinely a race against time. Early autumn is when the peppers reach their fullest shape and strongest coloring. And it's also when the season officially begins. Across fields spanning dozens of hectares, specialized harvesters start up simultaneously, producing the signature hum of modern agriculture. They move slowly but steadily, sliding harvesting arms into each plant, lifting the entire stem, and shaking it so the peppers fall onto the conveyor belt. From there, the stream of peppers passes through rotating brushes, suction fans, and continuous sorting systems that remove leaves, soil, and defective fruit, leaving only the high-quality peppers to drop neatly into the collection bins. Thanks to these machines, productivity has changed completely. A single harvester can replace hundreds of workers, and what once took a month to gather can now be collected in just a few days. At many large farms, weekly harvest volumes can exceed 300 tons, a figure nearly impossible to achieve with manual labor alone. This isn't just a story about faster harvesting. It's a clear example of how technology is reshaping agriculture. Fewer people, less time, and far more output, all while keeping product quality consistent. When grown in open fields, bell peppers can only be harvested during a few warm and dry months. But to sustain an industry that consumes millions of tons each year, growers have to extend the production season. The solution lies in greenhouses, where light, temperature, and humidity are controlled down to the smallest detail, allowing peppers to be harvested year-round. In this environment, the harvesting process also changes. Workers don't pull or shake the plants as they would outdoors. Instead, they use pruning shears to cut each pepper individually to keep the stem intact, because even a slight bruise on the stem can lower the fruit's grade during sorting. The freshly cut peppers are placed on plastic trays mounted on small electric carts, vehicles that can run continuously between rows barely 80 centimeters wide without breaking branches or scratching the fruit. Once the trays are full, the carts unload the peppers into a small trailer hitched to a tractor. Its low chassis allows quick loading, its tight turning wheels help it maneuver easily in confined spaces, and safety sensors reduce collisions. Crucial because even a small scratch can make a pepper deteriorate 30 to 40% faster. When an entire greenhouse block is finished, a line of carts heads straight to the processing area, where facilities can receive anywhere from tens to over 200 tons of fresh peppers per day, depending on the size of the farm. This is the key link that keeps the bell pepper supply stable throughout the year, regardless of weather or season. As soon as the peppers reach the collection point, massive hydraulic machines immediately lift the crates into the processing line. With a single tilt, an entire crate of bell peppers pours onto the conveyor like a waterfall. But instead of bruising, cushioned chutes and soft conveyor belts absorb the impact, keeping every pepper intact. Thanks to a precisely timed speed control system, up to 2,000 crates can be handled smoothly each day, an impressive starting point for the industrial journey of bell peppers. The first step in the industrial process is cleaning. Crates of bell peppers move into an automated washing system, rolling across massive horizontal brushes that strip away layers of soil as if they were never there. Immediately after, they meet a blast of high-pressure water combined with strong airflow, washing and drying the peppers in just a fraction of a second. After cleaning, bell peppers move into the most critical stage of the entire production line, sorting, where the commercial fate of each pepper is decided. On the system of rubber-coated rollers, the peppers rotate, not just to move forward, but to expose every part of their surface, including areas that are usually hidden, such as the bottom, the stem, and the grooves between the lobes. Above them, a multi-angle camera system captures 60 to 120 images per pepper, combined with high-precision 3D sensors and color sensors. Together, they record the pepper's size, shape, color uniformity, surface gloss, physiological ripeness, and any surface damage as small as 0.2 millimeters. Right after the scanning zone, each pepper enters an individual tray, a structure specifically designed for difficult produce like bell peppers, which have irregular shapes and thin, easily scratched skins. Each tray holds exactly one pepper, equipped with an ultra-sensitive scale with an accuracy margin under ±1 gram, along with an auxiliary rotation mechanism to complete any missing angles of data before the system makes its grading decision. In practice, if a sorting line can accurately grade bell peppers, it can handle almost any other challenging fruit or vegetable. No two bell peppers look alike. Their lobes are uneven, their shapes asymmetrical, and their value depends heavily on the perfection of their surface. This is why the market has more machines dedicated specifically to bell peppers than to apples, tomatoes, or mangoes, even though those crops sometimes have much higher overall production volumes. On the market, most bell peppers are sold whole in plastic bags. In the United States alone, the number exceeds 5 billion fresh peppers every year, meaning billions of those familiar bags you see on store shelves. But few people realize this isn't just a convenient packaging method, it's also a vivid demonstration of consumer psychology at work. Red and yellow peppers trigger appetite, while green suggests freshness. When all three colors sit next to one another, they create an irresistible visual pull, a mix of contrast and harmony that distracts you, makes you hesitate, and ultimately makes you far more likely to add to cart than you planned. However, plastic bags are only used for retail. At industrial scale, where demand is measured in tons rather than in bags, bell peppers are packed into cardboard cartons. Each box weighs 5 to 10 kilograms and holds 30 to 80 peppers, meeting the standards required for storage and long-distance transport. From there, fleets of refrigerated trucks line up and leave the processing plant, carrying bell peppers to supermarkets, wholesale markets, and even high-end restaurants across the country. After the sorting stage, the bell peppers are moved to the stem and core removal area. Here, workers use specialized tools, usually a cylindrical coring knife or a tube-shaped cutter with a diameter of about 25 millimeters, to trim the stem and clean out the entire core. Each worker can process an average of 400 peppers per hour. After being cored, the bell peppers are lightly blanched at 90 to 95 degrees Celsius for 2 to 4 minutes to soften the flesh, lock in color, and reduce the microbial load before canning. However, depending on the product line, the peppers may also be roasted instead of blanched. Roasting adds a natural smoky aroma and helps loosen the thin outer skin, making it easier to peel. After roasting and rapid cooling, workers use gloved hands to remove the loosened skin and trim off any charred spots, or on larger production lines, rotating drums and strong air jets handle the peeling automatically. Roasted peppers stay tender but hold their structure well, making them ideal for richer, more flavorful canned varieties. Whether blanched or roasted, the peppers are immediately transferred to the filling hopper and packed into sterilized tin cans. A 1.5 to 2% brine solution, heated to 80 to 85 degrees Celsius, is added to remove air bubbles and create a stable preservation environment. The cans are then sealed using a double or tryptoseam system, ensuring an airtight closure before sterilization. In the final stage, the cans enter a retort unit and are sterilized at 121 degrees Celsius for 20 to 30 minutes, eliminating all harmful microorganisms while preserving the pepper's natural crunch, color, and structure. Not everyone realizes it, but the thick skin and hollow cavity of bell peppers seem almost purpose-built for stuffing. And surprisingly, stuffed bell peppers were also one of Princess Diana's favorite dishes, so much so that she could eat them 2 to 3 times a week without ever getting tired of them. According to former royal chef Darren McGrady, her preferred version was bell peppers stuffed with zucchini, mushrooms, and rice, topped with mozzarella and parmesan, then finished with a smoky tomato sauce. Under heat, the pepper softens and turns sweet, soaking up the sauce, while the filling becomes firm and flavorful. The gentle sweetness of the vegetables blends with the salty richness of the cheese, creating a dish that is both refined and comforting, the kind of flavor that warms anyone from the inside out. When tossed in a hot pan, the crisp sweetness of bell peppers stays intact, while releasing their signature aroma. Just a few slices can instantly brighten the entire dish with color. They can be stir-fried with chicken, beef, pork, or simply with onions and mushrooms. And each combination brings out a different flavor profile. Chicken with bell peppers is light and delicate. Beef makes the dish richer and more aromatic, while a vegetarian stir-fry keeps the pure sweetness of the vegetables. It's one of the quickest ways to create a dish that's easy to make, visually appealing, and nutritionally balanced. From ancient myths to modern life, the apple has retained its mysterious allure, both as the sweet fruit of knowledge and as a symbol of the delicate boundary between desire and temptation. But why the apple, and not any other fruit? On the global apple map, China dominates production, accounting for more than 40% of the world's total output. while the United States conquers markets through technology and quality. With premium varieties like Fuji, Gala, Honeycrisp, and Golden Delicious, and the Mott's brand, which produces over 1.2 million bottles of apple juice every single day. Compared to oranges, apple juice is not only lower in acid and gentler on sensitive stomachs, but it also boasts higher levels of polyphenols and pectin, helping to reduce cholesterol, aid digestion, and provide powerful antioxidant benefits. And every journey has a beginning. Now let's step into the most radiant chapter of the apple story, the harvest season, where every beginning ripens into a golden season of abundance. An apple tree usually takes 4 years of patience to bear its first fruits, but after nearly a decade, once it reaches full maturity, it can yield thousands of apples each harvest season. Every August, the bright red apples begin to ripen in abundance, signaling the arrival of harvest time. Depending on their intended use, the apples are picked either by machine or by hand. At premium apple orchards where thousands of tons of fruit are produced each year to meet the demanding standards of fresh fruit markets, hand harvesting remains the top choice. In the past, picking apples from the highest branches relied on tall, precarious wooden ladders, the key to unlocking a golden harvest. But today, in modern orchards, that key has been replaced by semi-automated systems combining conveyors and motorized lifting platforms. Pickers simply stand on the platform as the machine glides smoothly between rows at adjustable heights, allowing them to reach every canopy safely, precisely, and efficiently. Once a ripe apple rests gently in hand, it is placed onto a conveyor belt that carries it straight to the sorting area, without a single bruise or scratch. Each machine can carry up to 10 large bins and move continuously between the orchard rows, doubling productivity and reducing labor effort by up to 30% compared with traditional manual harvesting, while still preserving the perfection of every apple, meeting the strictest standards of the world's most demanding markets. In contrast, for apple varieties used to make juice or cider, where appearance is no longer the determining factor, shaking machines have become the perfect choice. The intelligent mechanism features a steel arm wrapped in rubber padding, generating controlled vibrations strong enough to shake ripe apples from the trees without causing significant damage to the trunk or roots. Each hour, the most advanced shaking systems can cover dozens of hectares, boosting productivity by 4 to 5 times compared with traditional manual harvesting. Once the ground is carpeted with fallen apples, sweeping and collection machines take over the final stage. Rotating brushes close to the ground gently sweep the apples into neat rows, and the integrated suction and conveyor system immediately draws the fruit into the collection chamber. Fast, efficient, yet gentle enough to prevent bruising or damage. The apples are then lifted onto a conveyor belt, pass through a leaf and debris filter, and are transferred into bins at the rear of the machine. Once full, the bins are emptied into trailers for transport to the processing facility. And when the harvest is done, truckloads of apples roll toward the processing plants, where the journey of a billion-dollar fruit empire truly begins. As soon as the freshly harvested apples arrive at the processing plant, they are gathered in the raw material receiving area and quickly placed into temporary cold storage to preserve their natural freshness, crispness, and flavor before processing. For premium apples intended for fresh consumption, every batch must undergo a rigorous inspection by quality control specialists to ensure compliance with strict standards of appearance, uniformity, and food safety. Once the inspection process is complete, the qualified batches of apples are transferred to the processing line, beginning with a step that seems simple but is absolutely essential: washing. At the start of the process, apples are emptied into large circulating water tanks, maintained at an ideal temperature of 20 to 25 degrees Celsius, combined with continuous air bubbling and a diluted chlorine solution at a safe concentration. This soaking stage not only removes dust, soil, and surface bacteria, but also eliminates pesticide residues that may remain from cultivation and transport. The cleaning doesn't stop there. After soaking, the apples move through soft roller conveyors, sprayed with high-pressure water jets from multiple angles, thoroughly cleansing every crevice of the peel without scratching or dulling its natural shine. After being thoroughly washed and polished, thousands of gleaming apples move onto soft bristle roller conveyors, equipped with high-capacity air blowers that gently remove residual moisture from their surface. This step helps prevent mold growth and spoilage during subsequent stages of processing. The conveyor then carries the apples to a manual inspection station, where trained workers carefully visually examine each fruit, removing any that are bruised, scratched, or misshapen. This ensures that only the most flawless apples proceed to the next stage, the automated optical grading system, where precision technology takes over. And now comes the most precise and crucial stage of the entire process: apple grading using an automated optical sorting system, a technological breakthrough that reduces manual errors by up to 90% and determines the destiny of every single apple. The entire operation takes place on a smart conveyor system, equipped with color sensors, weight detectors, and high-resolution cameras. The system can identify size, gloss, tone, and even the smallest imperfections such as bruises, cracks, or discoloration, details that the human eye can hardly detect with precision and consistency. Apples that fail to meet standards are automatically removed by ultra-precise air jets, while those that pass are classified according to size, quality, and intended use. Apples with a beautiful shape, even color, and flawless skin are sent to the fresh apple packaging line. Here they are arranged into trays or packed into plastic bags, then sealed securely and labeled with full product information. Finally, the finished products are placed into cartons, stacked on pallets, and moved to cold storage, awaiting distribution to consumers worldwide. While the most flawless apples have already made their way to consumers around the world, the journey continues at processing plants dedicated to apple juice and cider production. Each day, a large-scale facility, such as Mott's USA, can receive thousands of tons of apples from farms across the region. Unlike table apples, processing apples don't need to look perfect, but they must meet strict standards for sweetness, crispness, and flavor to produce a pure, well-balanced juice. After being received, washed, and quality checked, the apples are fed into high-capacity grinding machines, equipped with high-speed rotating blades, capable of processing hundreds of tons per day. Under intense centrifugal force, the apples are crushed into a fine mash of pulp, juice, and peel, creating the apple mash, the essential raw material for the juice extraction stage that follows. The crushed apple mash is transferred to the pressing stage to extract its precious juice. In traditional or medium-scale factories, the drum press, a long-standing reliable technology, remains in use thanks to its simple design, durability, and ease of maintenance. However, the belt press has become the modern standard, favored by large industrial facilities for its ability to operate continuously, deliver superior throughput, achieve high juice recovery rates, and preserve the natural flavor of the apples. Each day, an industrial belt press system can process hundreds of tons of apples, achieving productivity 2 to 3 times higher than conventional presses. Under immense pressure, the juice is separated and flows through fine filtration screens, while the remaining dry pulp is collected separately. In modern factories, apple pomace is not wasted, but dried or pelletized for efficient reuse. Rich in fiber and nutrients, it is used as a natural livestock feed or biologically fermented to produce organic fertilizers. It also serves as a sustainable raw material for the green industry, processed into pectin, ethanol, pharmaceuticals, and natural cosmetics, maximizing the value chain of every harvested apple. The juice obtained after pressing is sent to the filtration stage, a crucial step that removes pulp, pectin, and impurities, ensuring clarity and natural flavor. Various filtration methods are used today, from traditional mesh filters to microfiltration and advanced tubular membrane systems. At this point, the process diverges into two distinct directions. For apple juice, the filtered liquid is transferred to heated mixing tanks to stabilize enzymes and improve clarity. This process occurs at 35 to 45 degrees Celsius for at least 30 minutes, allowing the breakdown of pectin and remaining colloidal compounds. The juice is then rapidly cooled to stop enzymatic activity before entering a tubular sterilization system, where it is quickly heated to 85 to 90 degrees Celsius and immediately cooled, ensuring microbial safety while preserving its natural freshness and flavor. In the production of apple cider, the filtered apple juice is transferred to the fermentation area, the most crucial stage in transforming fruit juice into alcoholic cider. Depending on the scale of the facility, each fermentation tank can hold anywhere from several hundred to tens of thousands of liters of liquid. Once yeast is added to the filtered juice, the fermentation process begins, lasting from 5 to 14 days under strictly controlled temperatures. After the yeast completes fermentation, the sediment settles at the bottom of the tank. At this stage, the clear cider is siphoned off and transferred to the aging phase. Depending on the type of product and the techniques used by each facility, the cider can be aged in large stainless steel tanks or traditional oak barrels. Aging in stainless steel tanks preserves the cider's fresh, crisp apple character, while aging in oak barrels allows it to absorb woody aromas, tannins, and natural compounds from the barrel walls, creating a richer, deeper flavor with a long, smooth finish. The aging period typically lasts from 1 to 6 months, and for premium ciders, it may extend up to a year. Throughout this time, technicians regularly take samples to monitor key indicators such as clarity, alcohol content, acidity, and microbial stability. Once the cider reaches the desired quality standards, it is passed through a fine filtration system to remove any remaining sediments, yeast residues, or impurities. Before bottling, both apple cider and juice must undergo rigorous quality control tests in the laboratory. Only batches that meet all specifications are approved for packaging. When everything is ready, the bottling process officially begins, the final stage that completes the entire production journey and delivers the product to consumers. First, empty bottles are sent through a specialized cleaning system, where they are thoroughly washed with sterilized water or high-pressure air at 70 to 80 degrees Celsius to eliminate microorganisms and remove any dust or residue. After drying, the bottles are automatically transferred to the filling section. Here, the automated filling system operates with near-perfect precision. Once filled, the bottles move on to the automatic capping unit. Caps, whether screw, press fit, or aluminum, are sealed tightly under controlled pressure to guarantee airtight closure, prevent oxidation, and preserve the product's natural flavor. The sealed bottles are then sterilized and dried before proceeding to the labeling section. Each label clearly displays the brand, origin, production date, expiration date, and traceability code. After a final quality check, the finished bottles are packed into plastic crates or cartons, stacked on pallets, and transferred to cold storage, ready for distribution to markets and consumers around the world. Upon arrival at the factory, the dump trucks or trailers loaded with chicory roots are sorted and processed according to the current intake capacity of the production line. Chicory roots, harvested early in September, often haven't reached optimal size or maturity. These are typically set aside and stored in cold chambers for an extended period. It's crucial that the temperature remains stable between 0 and 1 degrees Celsius to ensure the roots enter a full dormancy, preventing premature sprouting while preserving the internal energy reserves needed for the endive forcing phase later on. Chicory roots, harvested between October and November, are typically mature enough to proceed directly to the forcing stage in the darkroom, the beginning of their transformation into ivory-white endive buds, crisp, delicate, and among the most premium vegetables in the world. At the factory, entire truck beds are lifted using hydraulic systems, allowing tons of chicory roots to slide steadily into a large receiving chute. This chute feeds directly into the main intake hopper of the preliminary cleaning line. Just beneath the hopper, the primary conveyor system begins operating, guiding the flow of chicory roots onto a roller belt equipped with rotating rubber brushes and mechanical rakes. These components work together to remove any remaining leaf stems, clumps of dry soil, lateral roots, and coarse debris. Next, the roots pass over rollers with narrow gaps or a rotating mesh surface, allowing fine soil, small stones, and organic fragments to fall through. This phase isn't just about cleaning, it's a crucial preparation step that readies the chicory roots for their second life cycle. After the initial cleaning phase removes most of the soil and debris, the chicory roots move on to a deep washing conveyor. Here they pass through high-pressure water jets positioned along the belt, or are placed into a rotating drum washer for thorough rinsing. Interestingly, from an agricultural processing standpoint, some factories skip this washing step entirely, especially when the roots are already sufficiently clean and will be stored only briefly. After washing, the chicory roots are sent to the sorting and quality control area. Here, workers manually remove any roots that are broken, moldy, rotten, or incorrectly sized. Only roots that meet strict criteria, straight, long, undamaged, and of sufficient size, are kept for the next phase, bud forcing. Meanwhile, the growing racks equipped with trays, each divided into square cells sized to fit individual chicory roots, are first filled with cool water. This step helps establish a stable, humid, and temperature-controlled environment ideal for bud forcing. Once the trays are in place and filled, workers carefully insert each chicory root into a cell with speed and precision, ensuring the base of the root makes proper contact with the water surface. The roots are spaced evenly to avoid overcrowding, creating optimal conditions for uniform sprouting and producing high-quality endive buds. At last, after all the meticulous preparation, the strange journey of the chicory root reaches its most awaited chapter, the darkroom forcing stage, where the real magic begins. The first key to success is creating an environment of total darkness. Only in the absence of light can the plant's natural biology be deliberately redirected and controlled, steering its growth in a completely new direction. To achieve this, the environment is carefully controlled. Temperature is kept steady between 12 to 16 degrees. Air humidity is maintained at 90 to 95%, and oxygen levels are adjusted to slow down respiration and limit natural oxidation. As a result, the buds grow slowly but consistently, with reduced risk of rotting and a uniform, elegant shape, each one a flawless product of darkness and precision. Beneath each tray is a recirculating hydroponic system that delivers water and nutrients from the bottom up. This ensures the root bases remain consistently moist without water pooling on the buds, reducing the risk of fungal infections while encouraging the sprouts to grow upright, thick, and uniformly shaped. Inside the darkroom, the space is organized into multi-tiered shelving racks, each level holding hundreds of trays. This vertical layout allows thousands of chicory roots to be cultivated simultaneously in a closed-loop system optimized for mass production. The forcing process typically lasts between 20 and 25 days, during which the growth of the buds is continuously monitored by a network of sensors connected to a central control system. This ensures precise regulation of environmental conditions, allowing the sprouts to develop at a steady, optimal pace. If you want to become a classic-style farmer, try growing endive using the traditional soil forcing method. Instead of investing in complex hydroponic systems, this approach allows chicory roots to be planted directly into soil beds inside a dark room. The entire bed is covered with black plastic sheets to retain moisture, block out light, and maintain stable temperatures, creating ideal conditions for the buds to grow. Chicory grown this way often produces endives with a richer flavor, denser texture, and thicker leaves compared to hydroponic cultivation. Although it requires more space and yields less, this traditional model is still practiced on many farms across Europe, especially in Belgium, the birthplace of endive. At the end of all the patience and meticulous labor comes the most rewarding moment: harvest time. When the endive buds reach 12 to 15 centimeters in length with uniformly pointed tips, tightly wrapped leaves, and no gaps for light to enter, they are considered perfectly mature, forming what many call pearls of the dark, known for their crisp texture, delicate sweetness, and the near-complete absence of chicory's natural bitterness. In modern facilities, the harvest is assisted by rotary disc cutters, machines hailed as essential tools in the final stage of production. Their continuous and precise operation can boost productivity by 3 to 5 times compared to manual cutting, while significantly reducing damage caused by improper handling. The machine features a large rotating disc divided into multiple compartments, each designed to securely hold the chicory root horizontally. The entire operation runs continuously and smoothly, with each rotation typically processing 4 to 6 roots, depending on the machine's configuration. Once separated, the endive buds drop gently into a collection chute and are transferred to a sorting conveyor, where workers inspect and remove any buds with loose leaves, deformities, or imperfections, ensuring that only flawless specimens continue on to packaging. After harvesting, the old and excess endive leaves are collected separately. Rich in fiber and nutrients, they're often composted into organic fertilizer or repurposed as livestock feed for animals like cows, goats, and rabbits. The spent chicory roots, having completed their role in sprouting, are also separated and sent for biological processing or converted into biofuel. This allows for the recovery and reuse of up to 95 to 100% of the plant's biomass. It's a prime example of the closed-loop cycle in modern agriculture, where every part of the plant is utilized, not only to produce premium endive, but also to support environmental protection and sustainable development. To save time and ensure absolute hygiene, modern farms use automated robots to wash the growing trays after each endive cycle. These systems use high-pressure water jets and rotating brushes to thoroughly clean every corner, removing soil, root debris, and any remaining microorganisms. After sorting, the premium-grade endive buds are transferred to the packaging line in a chilled environment. Depending on the target market, the buds may be packed in breathable mesh bags, plastic trays with shrink wrap, or vacuum-sealed packaging, extending shelf life up to 2 to 3 weeks while preserving freshness and structure. Finally, the packaged units are labeled, tagged with traceability codes, and stored in cold chambers awaiting shipment. And just like that, from a humble root grown under open skies, through a dual life journey between light and shadow, the endive bud is born, a symbol of refinement, precision, and sustainability in modern European agriculture. That is why 99% of America's walnut production comes from here, exported to over 50 countries, and renowned for their consistent size, mild sweetness, and high omega-3 content, especially prized in European and Japanese markets. Though walnut trees take up to a decade to reach full productivity, once mature, they can bear fruit for more than a century, turning each tree into a living legacy that nourishes generation after generation. But before these century-old giants can yield their bounty, the journey begins much earlier, with the careful planting and nurturing of young walnut trees. In spring, as the weather warms and the soil becomes moist, it marks the ideal time to plant walnut saplings. Once the soil has been prepared with these advanced plowing machines, the process of planting walnut saplings begins, a seamless blend of modern technology and the skilled hands of farmers. The machines create straight, evenly deep furrows with their sharp plow blades, tailored to suit the soil type. Once the furrows are ready, farmers carefully place each sapling at the correct distance and upright position, ensuring the best conditions for the trees to grow and thrive. After the saplings are planted, walnut trees are regularly watered using modern automated irrigation systems. These systems ensure the soil maintains an ideal level of moisture without wasting valuable resources. Additionally, weeds around the base of the trees are cleared periodically using specialized mowing machines. These machines are equipped with sharp blades that cut weeds precisely at ground level without disturbing the tree roots. This keeps the area clean and open, providing the roots with ample space to grow strong and healthy. At the same time, American farmers rely on spraying machines with long-range nozzles and adjustable pressure systems. These sprayers ensure that protective treatments are evenly distributed from the roots to the top of the tree, offering effective protection against pests and diseases. Thanks to the combination of advanced machinery and the meticulous care of farmers, young walnut trees are given the best possible conditions to thrive, paving the way for a productive and successful harvest in the future. After 5 to 7 years of patience, and with prosperity beginning from the 10th year onward, fall arrives. As the leaves turn golden and the walnuts, round and deep brown, hang heavy and ready to drop from their branches, the season of harvest begins. So, how do these walnuts get off the branches quickly and efficiently? The secret lies in the use of modern tree shakers. These advanced machines feature a strong yet flexible mechanical arm that reaches out and grips the trunk or large branches of the tree. The gripping area is padded with soft material to prevent scratches or damage to the tree itself. Once clamped onto the trunk, the machine unleashes perfectly calibrated vibrations, powerful enough to shake loose the ripe walnuts in seconds, yet delicate enough to leave the branches, leaves, and unripe fruits completely unharmed. Once the walnuts have been shaken free and carpet the orchard floor, specialized sweepers move in to corral them into perfectly ordered rows. Equipped with rotating brushes at the front, these sweepers work with a balance of gentleness and efficiency. As they glide between the rows of trees, the brushes guide walnuts from every direction toward the center, lining them up into neat, uniform rows. Made from flexible yet durable materials, the brushes ensure that not a single walnut is scratched or damaged in the process. The sweepers also feature adjustable height settings, enabling them to adapt seamlessly to any terrain, from smooth, level ground to fields with grass or scattered rocks, ensuring that not a single walnut is left behind. After the sweepers have lined the walnuts into perfect rows, modern harvesters take over, swiftly collecting them into storage bins with remarkable efficiency. These harvesters use a front-mounted sweeper to guide walnuts onto a conveyor belt system built for speed and safety. As the machine glides down the rows, the belt lined with grooves and soft padding carries each walnut securely, ensuring the shells remain perfectly intact. Rather than relying on suction, the system uses a gentle lifting and continuous movement mechanism that carries the walnuts smoothly from the orchard floor to the storage bins at the back. At the end of the conveyor, the walnuts are poured directly into large bins hitched to trailers or harvesters, ready to be transported to processing facilities before beginning their journey to consumers worldwide. With the orchards cleared and the bins filled to the brim, the journey of walnuts now shifts from the fields to the factory, where the real transformation begins. The factory process begins with preliminary cleaning, where branches, leaves, and stones are carefully removed, leaving only the freshly harvested walnuts. They then pass through dehusking machines that strip away the green outer layer, preparing the nuts for storage in specialized warehouses, kept in perfect condition for the next stages of processing. The first step involves placing the walnuts into large water tanks, where advanced cleaning systems come into play. These systems include high-powered rotating brushes and strong pressure jets that work continuously. The brushes effectively scrub away dirt, soil, and other debris clinging to the walnut shells, while the high-pressure jets ensure every crevice of the walnuts is thoroughly cleaned. After washing, the walnuts move into large industrial dryers, where temperature and humidity are carefully regulated. Over several hours, the process removes excess moisture from the shells, prevents mold, and extends shelf life. Just as important, it preserves the kernel's natural sweetness, texture, and aroma, ensuring the walnuts remain as fresh and flavorful as the day they were harvested. After drying, thousands of tons of walnuts are stored in vast warehouses, carefully preserved and awaiting the next stage of processing. Around 40% are packed directly into large bags, ready to be shipped as whole walnuts, perfect for tossing into salads or enjoyed as a wholesome snack. The rest move on to further processing, where they are meticulously selected and transformed into value-added products, such as walnut candies, silky walnut milk, and gourmet specialties. Once the walnuts are perfectly dried and preserved, they move on to the next critical stage, cracking open the hard shells to reveal the precious kernels inside. These machines operate with high precision, using carefully calibrated braking mechanisms to apply just the right amount of force. This careful balance is crucial because excessive force could break the kernels, affecting their quality and value. After the shells are removed, the walnut kernels go through an automated sorting system to eliminate any leftover shell fragments. Vibrating sieves or powerful air blowers ensure that all debris is thoroughly removed. Next, the walnut kernels are carefully inspected using laser scanners, which can process thousands of nuts per minute. These scanners detect and remove kernels with cracks, uneven coloring, or tiny impurities that may still be present. Thanks to laser technology, only walnuts that meet the highest quality standards proceed to the packaging stage. Once the walnut kernels meet quality standards, they are sent to the packaging area. Here, the kernels are carefully weighed and sealed into airtight bags or containers to maintain freshness and ensure food safety.